geometry. We're practicing our riders, we're practicing all our theorems. The moment the sum starts, you've got to read all the stuff that's next to the sum. So the sum said that y, v, and v in were both tangents. You don't assume, you don't accept, they've got to tell you that. And the moment that they do tell you that, please make an indication that you see that it's a tangent. Because first thing that pops to mind is what? The tangent theorem. If there's two of them, which isn't always the case, it's the participants, right? Which means what? What's going to be equal? N1 and Y2 are going to be equal to each other, for sure. Because of these two being equal to each other, because of the tangent theorem, two tangents from a point. So when you start off, I always tell you to start with number 1, 2, 3, 4, 5. But if it's tangents, you immediately know you're going to go for those theorems. So you already know that. And where's the tan chord theorem coming into? N1 would be equal to 65. You see it? Because it's the tangent, there's a chord. Please remember that the chord can't stop somewhere in the middle of nowhere. Chord has to go to the other side. And you take your fingers on those 2 points on the chord and you go to the other side, which will mean that it's going to be equal to A, that is 65. My first question was, get me some other angles that are also 65. So there's one. So obviously then this will also be 65. And which other one?
S1.
How come S1?
Because of corresponding angles.
Ah, excellent. Because if you don't indicate it for yourself and highlight it, and I don't know what you must do to realize it and see it, definitely these two angles are corresponding. Do you see it? Corresponding angles. So this will be 65 as well. That little piece in there. So there's the 3. If they say 3, usually there are only 3. It's not to say that it will never happen that there's more, but if they say 3, then there's usually 3. So we can already start doing that. There's other sums also to do, we'll get into them, but let's go through our theorems, because ma'am says to you, theorems, use the theorems. How many marks have I got so far? Nothing, because I haven't written down anything. I'm doing the sum on the sketch, finding out, so that's why we give it to you quite big, workable, so you can see what's going on there. Let's go through our theorems. Is there a center in this circle given? No. And they would have said if there were. There's nothing. So that means line from the center, perpendicular to a chord, can't be there. Angle at the center, twice the angle at the circumference, can't be there. Semicircle, can't be there. The moment that there's no center, there are theorems that you cannot take. The first 3 as well as theorem 7. Because what's the other tangent theorem that you've got? If you have a radius to the tangent, it'll be perpendicular. That one's out because you don't have a center. So you've got to know, the moment that I say no center, then the first 3 and number 7 falls away. You've got to know them off by heart. So if I say number 7, please don't write number 7. But if I say it, you should know it. So then let's get to the other stuff. Theorem 4 was the bow tie. Bow tie. Seeing any bow ties? Not on the sketch. Not on the sketch. On the circle, I was going to say, on the circle. There's no bow tie here. But doesn't it kind of maybe look like some things going on here? But it's not inside the circle. But look at the second question. Prove something is a cyclic quad. The something that they're looking at is VYSN. VYSN. Then your first instinct is, ma'am, it's not, because it's not in a circle. You don't write that ever. We've discussed this many times. The reason for something being a cyclic quad is how many reasons? There are 3. There are 3. So let's get back to our routine. We've done bow tie now. We said we don't see a bow tie. Okay. Theorem 5 and 6 is all about the cyclic quads. What do you know about cyclic quads? Opposite angles are supplementary. Exterior angle. Is this available in my sketch? In the circle, I'm not seeing a cyclic quad. Do you agree?
Yes, ma'am.
Okay, so that can't be there. Then we've already went through the tangents. But now, if I have to prove a cyclic quad, even if it's not on the circle, even if I drew it somewhere over there, and I ask you, is that a cyclic quad? You don't say no, there's no circle. There's got to be either one of three reasons. What are the three reasons? Converse of opposite angle supplementary, or exterior angle equal to the opposite, interior one. But then there's another one, the bow tie. The opposite of the converse of bow tie, and I'm seeing it here.
Yeah.
Look at this thing. Where is it?
S2 and Y2.
S2.
And Y2.
How do you know what S2 is? You know already what it is, because I need them to be the same. Are they the same? Not that I see at the moment. So how will this thing be a cyclic quad? It is bow tie. But which angles? N2, no? No, N2, no. Do this. Yes, S1, I hear it. S1. And?
Or and Y.
S1 and N1. Just do this. It's not just always straight up that those two would be equal. In this case, here's the chord that will subtend it going to N1 and going to S1. But you've got to look at it, and sometimes it helps to turn your book around, because I can't turn the board, so I've got to do this. Do you see it now?
Yes, ma'am.
S1, N1, both subtended by V1, also subtended to N1. So if they are equal, it's a cyclic quad. But you have to see it. See how they are leading you? You're going to get these angles. Once you got them, that'll help you to find the cyclic quad. Okay, let's start writing first of all before we carry on. So to find those angles that are all equal to 65, where did we start?
We use N1.
We said N1 was equal to, let me just get a pen. N1 was equal to which one did we find it equal? To A, because it was tan chord theorem. And remember, you have to give me the reasons that are acceptable, not your own tan chord theorem. Then that's tan chord theorem. You can't tell me this, okay? Okay, so, and then which other one? We said Y2 is equal to N1. Why? Yeah, okay, I'm hearing two reasons, because they both have to be here. Why is it 65? Two tangents from a point makes them the same distance. But why are they both 65? Because angles opposite equal sides. Do not write isosceles triangle. Okay, so the reason is two tangents from a point outside of the circle will be equal in length, and angles opposite equal both of them. So that could be worth 3 marks for that one step. The answer, and there were two reasons. Some people would rather say, no man, let's first say YV and VN are equal, reason, two tangents from a point. Next step, then those angles are both 65 because of angles opposite equal sides. And please remember when it should be sides opposite equal angles. Make sure you distinguish. Then the other one that we got was?
S1.
What was S1 equal to?
That equals to
To AY.
corresponding.
Because of that? That's it. AN parallel to SC. You will not get the mark if everything is not here. So this question was worth 6 marks, right? So that should have been 2 marks. Tan chord theorem is a new grade 11 theorem. That would have been worth 3 marks, because a lot of work. And then this one is really grade 8 and 9. So I would have given 1 mark. Meaning, if the parallel lines weren't there, you didn't get them off. No reason given whatsoever, you didn't get them off. Just 65, you don't get them off. It has to be everything perfect. 6 marks. Think about it. 6 marks, if we do a key sum, is a huge sum and difficult. How difficult was this in comparison to a difficult key sum? Quite easy, don't you think? And it's all about practice, practice, practice to get it written down in the correct way. You can get a lot of marks from geometry. Practice. Okay, finding the cyclic quad. So we see it. You never ever write no, it's not, because it's not on a circle. Then you can feel my hand coming behind you. Okay. Why would it be? 1 of 3 reasons. We found out that it has to be the bow tie in this case. Can you see the bow tie now?
Yes,
See those 2 angles being equal, but you don't have to tell me that. I'm seeing N1 equal to S. It's 1, sorry. That was equal to 65. And my reason?
Proven.
Can't you see? It's already proven. If you want to say proven there, you don't have to give me a reason. We know it's 65 for lots of reasons already. And therefore, it will be a cyclic quad. That's it. No, the reason is
Converse.
converse of
Angles in the same circle, so
okay, which would have been 2 marks like that. Not for saying it's a cyclic quad, because that was my question. Right, how do we prove a triangle is isosceles? Don't even look at the sketch.
Two angles
If 2 angles are equal, the sides should be
equal.
the same. So if I'm looking at ASN, let's find it. This one here. I should be finding the same angles. No, it's not to say that it's 65, by the way. It's not to say that it's 65. If these 2 are the angles that are the same, it would be 115, which is left of the 180, divided by 2. It's a possibility. Nobody said it had to be those 2 that are the same, or those 2 that are the same, or those 2 that are the same. We don't know. We've got to find the angles to be able to see which ones are equal, so that we'll know which are the sides that are equal to each other. Okay, ideas. More parallel lines, maybe.
S1 is equal to N2.
S1 is equal to?
N2 and 3.
Why would that be?
Because of corresponding.
Corresponding angles is only those 2 lines. So those are corresponding, but this whole one would be corresponding, well, not corresponding, I'd rather say interior angles there. V2 and all of them should be 180, but I don't have the information. Do you agree? Okay? Another is 2 and 3. Why?
equal to 115 because of co-interior angles.
2 and 3.
That's
2 and
Okay, so they should be equal to each other, but equal to how much? I don't know. Do I?
Doesn't Y3 and 2 make a 90-degree angle? And then
Why? Not a radius. On the tangent, okay? You've just proven, please take note. These sums are scaffolded, built upon each other. So you've got these angles to use. We've already used them actually, and we're going to use them some more. But the fact that that VYS in this black quadrilateral is a cyclic quadrilateral should also help me a little bit.
So isn't this
Or not?
Yes.
Can it? Maybe, maybe not. This will be the exterior angle. If only I knew what the opposite interior angle was. You agree?
Ma'am?
Yes, you see something. That's right. Remember, there will always be more than one way to do the sum. Yes? Say what you see. Because this is now how we are working. Remember, let me help you a little bit. If that's 65 and this is 65, why? Now that it is a cyclic quad, I can say it. So that's also 65, okay?
N3 is 65 alternate angles.
Then this will be 65 because of alternate. Be done. What did I try to teach you here? If they told me to prove that it's a cyclic quad and there's another question after that, chances are 9 out of 10, not 100%, that you should use the fact that it's a cyclic quad to get to the next one. How do I use it? Because it's a cyclic quad, then S2 would be the same as Y2, making it angles in the same circle segment. Because I now know that VYSN is a cyclic quad. You don't have to write that there, I'm just adding it for yourself. Because I know this, that's why I could say 65. And if I have that 65, that brings me to A3. Because A3 and S2 are alternate angles. Now guys, actually, you've already said that those lines are parallel, so you don't really have to put it here, but I don't even want to mention that. I said to you that if you write corresponding angles, alternate angles, co-interior angles, you always write them too. You cannot forget it, don't do that. Just be safe. And then I've got to say, well, do you see, man, that A is equal to, oh sorry, it's not A3, this was N, I'm sorry. N3 was equal to 65. So that means A and N3 are the same. Prove it if you want, or just like that, it is so, and therefore, it's an isosceles triangle. Do I have to say which sides? They don't really have to say, but my reason's going to say everything. It's because of
Angles converse.
Not converse, there's an actual theorem. Sides
Equal.
opposite, because there's an actual theorem that says it. You don't just say converse. If it's angles given and you've got to prove the sides, you say sides opposite equal angles. If it's equal sides, you say the angles are equal because it's angles opposite equal sides. Sides opposite equal angles. We're proving that the sides are the same because it's sides opposite equal angles that we've got there. Now you can then say that AS is equal to AN, because that is the truth, right? No, I'm wrong. These are the equal ones, it would be AS and SN. But did they ask me that? If you don't add that in, that's fine. But you could say AS is equal to SN, making it a isosceles triangle. Okay, it's not written in stone the way that you should write it over there. They didn't say which sides are equal, maybe you should add it. It's not really necessary.